I want to give you just a brief overview of, what is the Solar Decathlon, and so it kind of gives you an idea of the type of things that had to be on our mind as we were starting to work as a team and putting together all of our design ideas. So here you can see this is actually a competition. It's a Department of Energy sponsored event. And this was actually the 5th time, the 2011 event was the 5th time that this event had been held. And they actually set you up as a village. So they select 20 teams from around the world to actually be able to build the homes, bring them over, and set them up as part of the village for the competition. And these teams are coming from China, from Germany. We had a team from Belgium. So it's truly an international competition that all these technologies and ideas and culture are all being brought into this same competition. A couple of the pieces that you can see here are just kind of this idea of the neighborhood, which I think, we were speaking a little bit earlier about this idea of being able to walk through what does a solar or an energy efficient neighborhood look like, and the opportunity to see 20 different varieties of what that is, I think is a really important piece of this competition. And we're actually just closing in 2 weeks from I think this time period, the 2013 competition will be opening out in California. So this is an exciting point for us to be able to see what the next group behind us will have accomplished with the competition. So these are the areas that we actually were pursuing, and so it's a true decathlon, 10 competitions. You can see it's a pretty wide spectrum of things that we needed to achieve. It wasn't simply the architecture of the building or the engineering, but actually also how well we can communicate that. How affordable is this product to the public? So being able to actually share each of these as individual components, as whole systems, as a whole building, and then also how we share that with others. Made for a really interesting team makeup that we had 10 disciplines from across campus. So all the way from architecture and engineering that were, kind of expected in that. We had business students, we had graphic designers, we had culinary students. We actually, as part of going through this process, you're actually demonstrating daily life in the house. So you're doing loads of laundry, you're simulating showers, you're cooking dinner parties, and we actually had to host our competitors in our home and they got to judge us. But it was, how much energy are you using on your meal? How did it feel as a human being in that environment, enjoying that meal together? Was it comfortable or not? And so a lot of the pieces that James was speaking about lessons learned with lighting and the color of that are actually important to that experience within the space. So here's a little bit of a makeup of our team. You can see the wide variety of kind of where all of these groups were coming from. I think to me it was a little bit unexpected to see, we knew we needed graphic designers, but when we actually got down to it, having a team that included 28 graphic designers was something that I had not anticipated, but they made wonderful things like this image to help us convey our story. And I think we're a great part of helping make us successful. So when we looked at, what we're as a team, we all got together, all of the disciplines, and we sat in a room and we wanted to know what is important to the team. What are the things that we want to keep in mind as we pursue this design? And so you see here 6 concepts that we set out as being, these are our goals. These are the things that we want to achieve. So having the transparency in the views and obviously harvesting the sun's energy, which is kind of the point of the competition. Leaving a small footprint, having space that transforms, which allowed us to remain as a compact unit, and then having the ability to control your view and your ventilation. So one of the other pieces that we wanted to keep in mind is actually Tennessee as kind of an inspiration for our team and our design. Where do we come from and why does that matter? So we were able to look as far back as Cantilever Barn as a structure to, there were reasons behind how all of that structure were built, that you have the loft to keep the feed dry, you have the shelter for your animals, but also looking at things like the World's Fair and the Department of Energy being located here. We have a lot of really great kind of sources of inspiration, both historical and I would say technologically driven, that we could look to, and I think really helped our team when you are taking a message from Tennessee to go up to the National Mall and present that to the world. I think that was a really strong message for our state and for our university. So hopefully you can see the contrast here with the lighting. But so the idea of living compactly, we wanted to be able to take this as one unit. We had studied all of the previous houses and a lot of other examples of modular homes. And so we actually learned a lot from kind of the teams that went before us of the complications they faced when they took multiple units and tried to put them together. Even as simple as the things that we learned from trying to put it together ourselves with the little prototype house. So we actually have one unit, and you can see that we have two enclosed what we call cores. And so there's actually a core that incorporates all of the mechanical and electrical equipment. And then on the opposite end is actually what we sort of refer to as a private core. It's enclosed as the restroom space, and then on the outer wall of that is actually where it's not really a Murphy bed, but a bed that actually slides up into the wall, so it's very similar to a Murphy bed. And so the idea is everything between those two cores is able to be flexible throughout the day, throughout the season, so that as you're entertaining a dinner party, that you have the ability to entertain that with lots of space. When you're just at home and you're having you want to read a book, all of this had every function in mind. And then you can see that the majority of both of the north and south walls were glass. And the thickness of that was, I think the next slide probably, we getting close to that?
Interior.
So you can actually see what we chose to do was the southern facade is actually on your right, and we chose to have the larger lights of that be clear glass. And part of that was allowing us to collect that light and that heat from the southern side of the home. And then on the northern side, we actually chose to use a frosted glass, which it worked for our cases, that it actually also supported the privacy for the way we were oriented in the neighborhood, so that our front yard had kind of a built-in blind system in a way. But this facade system, actually, we'll get into in a few minutes, that is it's a newer system that I would say in homes, that we actually, it was lessons learned from that greenhouse space. But you'll see the lighting that's incorporated along the edge. These were actually color changing LED lights. And so we were actually able to do some programming that we could set them to be more natural tones. So in the morning, you can set it to have a little bit more of a red color that actually has a little bit more of mimicking sunrise. And in the evenings, give it a little bit more of that orange sunset glow. So there were a lot of really interesting things that we could do with that throughout the week. Even with hosting the dinner party, of being able to set that color so that the space felt more comfortable and more intimate.
I think they're set on Tennessee orange in this photo. It's a little washed out.
So this is another image of the interior looking back. I apologize, let me flip forward for you. This image is actually looking from the kitchen space back towards the living room, and you can see the foot of the bed is projected just a hair there. And then this is actually looking back towards the kitchen. One of the pieces that we wanted to make sure we did is everything had a purpose. So these walls actually, they're not just walls, but they actually hold pieces of the home. So this is actually, the kitchen doors are able to fully enclose that, but all of the oven, the dishwasher, everything is incorporated into the cabinetry to have one solid look to it. Do you want to go?
Sure.
Go ahead.
So this drawing is a section through one of the outside walls. So if this one is facing south, this is the outside of the wall, and then everything that you see in black is slicing through that wall. This depth between the inner and the outer glass is on the order of about 14 inches. So this was the concept that we started out with the UT0 prototype. It was 4 feet, and it was only switchable by a human moving the wall back and forth. Now we've collapsed this down to that 14 inches. We find that it still has the same thermal efficiency that it did before in terms of being able to heat air for us, but it takes out much less area of the building. Plus, instead of having the doors go through this zone, we have the doors go around on the short ends of the building so that we don't break that zone of heat gain every time we open or close a door. And over on the side, I think you can see a little bit of our dynamic modeling. We did several different tests on this structure as we were designing it to see where the light and where the heat would be in the space. And to kind of, well, to give you a little insight in the next slide, there is a flow of air that we channel through this cavity. Is the next slide the? Yes,
Yeah.
let's do this. Much more clear, right? Oh, it gets washed out a little bit. Well, anyway, so up here, this would be the heating mode. Imagine that what you're looking at is the section of our home, so that that line represents the south, this line represents the north wall. And this would be the sunlight that is impacting it in the winter. So again, as in the prototype, that winter sun comes in under the overhang. So that winter sun hits the glass unimpeded, and let's say we have a 30-degree temperature outside, we can raise that temperature about 30 degrees in that cavity so that we're allowing 60-degree air into the home. If the set point that we want to reach is 72, then that means the heat pumps, and we had 2 mini split heat pumps, only has to raise it 10 to 12 degrees for you to be comfortable. So in that regard, in the winter, during the times that we have sun, 2/3 of our heating is already taken care of just by the orientation and the design of the envelope. Now, to prevent heat loss on that north facade, when we are done with that air inside, we exhaust a little bit of it out that north facade. So what's happening is there's continuously a stream of air that comes inside the home, the mini split, heats it or cools it as necessary, and then we exhaust it out the opposite side. So this would be the winter heating mode, in on the south, out on the north. Now the opposite happens in the summer. In this version, we're getting basically free heat. But in this version, we're actually creating what we call a dynamic R value, or a dynamic insulating layer. So here, if we have, on a hot day, we have 90 degrees Fahrenheit, but we're pulling that air in on the north facade, which would be in shade. We're bringing that inside, and then we're using that air to be our fresh air. We're cooling that as we need to, and then we exhaust a little bit out of that on the south side, which is also now completely overhung by that sunscreen, so that we're creating that dynamic barrier of insulation around the house. And what we found in this is that we're able to achieve between about an 18 and a 25 R value, which, to put it in terms of standard residential construction, that is about the same or better than a 2x6 stud-framed wall with insulation, gypboard, sheathing, and brick. And in our house, it was a wall that you could look completely through. So there's some technology in this home. This is some of our HVAC system components. We used 2 mini split ductless heat pumps in the home. One is in each of those 2 cores that Amy showed you in plan. Together, it's about a 1.28 ton capacity for cooling, but we don't actually need that much. The reason that we have more capacity than we need is because of the rules of the competition. We would have an open day when we had tours of the general public coming through the home. At 5 o'clock, we had to shut the house, get everybody out, and by what, 7 o'clock?
At 5:30.
5:30, oh my goodness. We had to have the house at operating temperature to be able to start the monitoring competitions. So we had to have extra capacity to either be able to heat or cool that house to get it to our set point immediately. So that's why we have extra capacity. And then this is our energy recovery ventilator that moves air between the 2 facades. The energy recovery ventilator passes the streams of air so that heat is transferred from one side to the other, but not the air itself. So it's a very efficient means of ventilating a home without changing the interior temperature. So we benchmarked the home, and you can see on this chart here's a living lighthouse in blue, and the average builder home benchmarked to 1,000 square feet is in red. So overall, we're using about half the energy per year to heat and cool that house. And now we talk about the solar array. The array that we used on the previous project, the UT0 prototype, was a bifacial system. It was made by Sanyo. We were very interested in sourcing as many American-made products as we could on this home, so we used Solyndra. If anyone has heard of Solyndra, it bankrupted itself about a month after we bought our panels. But I have to say, it's a very good design, and I can show you why. This diagram, you're looking at 3 of the Solyndra tubes in section. This is our reflective roof, and this would be the direction of light. So the reason that this 360-degree tube of photovoltaic or energy-producing skin makes sense is because it doesn't care where the photon hits it. As long as light hits it somewhere, it makes power. So that works for direct, ambient light, and also any light that misses it on the first pass and bounces up actually can produce power on the back side. So hugely valuable for us. I really do credit this for being the reason why we got first place in energy production. We were able to make power early in the morning and later in the evening than most people. This diagram is a little bit hard to see. There's a gray line that peaks, and there's a blue line that is sort of more of a gentle curve with broader shoulders. The blue line represents the energy production over the course of a day for Solyndra, and the gray is for a standard solar panel. So a standard flat panel collector is going to peak higher than we will. They'll produce more power at noon, but we are actually able to produce more power early in the morning and later in the afternoon, which if you look at the area under the curve, we had more power. We also did exhaustive modeling of the home before we even took it to Washington to make sure that we had the equipment and we had the energy budget to do things correctly. So here you can see this is the energy use as it broke down for the competition. Heat is pretty much 40% of what we used. Lighting is very small. Water heater was 21. And then we would compose it against a chart of the number of days of the competition, and we looked at the energy produced versus the energy consumed. And so in this chart, the black is what we produced, the red is what we consumed. Now, in some areas you can see that we had peaks of consumption that did not hit the peaks of production, and that is not unusual. The great thing about the Solar Decathlon competition is it does push people in the direction of being grid tied. So the intent is to create net zero, not necessarily free from the grid. So if we again take the area under the curve, we produced far more power than we used, but we did not necessarily line up a peak in production with a peak in use, which is the way I think any modern grid would work. So we, over the course of the competition, put far more back than we used, but on certain times our peaks did not align. So that's something that myself and one of my colleagues at Oak Ridge National Labs, Bill Miller, are looking at. Are there ways to make those coincide more? But to be honest with you, I think the best idea is to have a home that has the ability to produce its own power but is always grid connected. That way you always have the ability to push it if you don't need it and to pull it when you do. Okay, so this one I think is kind of interesting to me. First, we have total energy consumption over the course of a year. We've, again, benchmarked a similar sized builder home at 1,000 square feet. Ours is approximately 1,000 square feet in blue. And you can see that we're somewhere between half to 2/3 better in terms of what amount of energy we use over the course of a year. Part of that is building small. Part of that is building efficient. And the other part of that is being able to operate it efficiently. This is the interesting diagram for me. This is the percent of energy that the Living Lighthouse components used compared to a standard home. So this is a standard home, this 100% mark. Our downdraft cooktop vent used exactly the same amount of energy as anyone else's downdraft cooktop vent. But where it gets interesting are things like lights. We used about 12% the energy of a standard home for our lighting. We had a mix of light-emitting diode in our floors, light-emitting diode in our can lights in the ceiling, and then we had strip fluorescents that had a step dimming feature for general illumination. So well lit during the evening and then day lit during the day, and that translates to the 12%. The other interesting thing was our refrigerator and freezer. We used a refrigerator that was an American-made product, a rather small, I shall say, refrigerator, not a full size as you would typically imagine it. But what we were able to do with that was it had two compressors in it. So you put a lot of groceries in it, it runs both compressors, gets everything cool, and then to maintain temperature, it steps back to one compressor. And we also worked that in conjunction with our water heater, which was at about less than 40% of the energy used in a standard home water heater. It was a heat pump-based water heater. And we put it in the mechanical room where we put all of our waste heat items. So we had the inverters for the solar system, we had the washer and dryer in that room, we had our computer in that room, and we also had the back of the refrigerator where the coil is, was open, dumping all of its waste heat into that mechanical room. So all of that heat that we would have to condition out of the home anyway The heat pump drove it from the air in that mechanical room straight into our hot water tank. So we got first place in hot water. So there's some interesting things that weren't necessarily complex designs, they were just smart thinking that got us ahead. We did have an automation system for this home. It gets pretty complicated. You know, we have all of these systems that have to work in conjunction with one another. And this is one where I really like to talk about how far we've come. Let's go ahead and go on to the next slide. So this was based on an iPad. We were platform agnostic. Could have been an iPad, could have been an HP device. It didn't matter. This is the screen you would get because you would dial up through a web connection. Its default setting was it would tell you interior and exterior temperature. It would give you some hot buttons to go to certain functions, and then it had the menus on the side to control everything. We can control the blinds from there. We can control the media, temperature. Here's what it looks like when you pull up your thermostat. You can control everything from that iPad. Can it continue? Here's the lights. So here are our floor lights, the red, green, and blue channel. So if you want to dial in Tennessee Orange, this is where you do it. And then this was our one button setup. We call these moods. So this would be something where if you're in the home and you're setting up to entertain, which is a cocktail glass, I love that logo. So you're about to have folks over for a party in the evening. If you press that one button, it will put the exterior blinds to a preset where you want them. It'll set the mood lighting, whatever color you've set. It will turn on the lights maybe in the dining area, but dim the ones in the kitchen area. It can turn on the light outside to welcome guests. It can turn the stereo onto the channel that you want it to be on, all with one button. Because we have so many complicated systems, we did not want this to be something that felt like an onerous task every time you had to set up for an event. So that one's pretty nice, and I think the opposite of this would be vacation. So you had one button that you could press on the way out that would put everything, you know, close all the blinds, turn all the lights off, put everything in power saving mode, and potentially even send you an email every once in a while to tell you what's going on. So that was great. Let's move on to is that the last one with the automation? Okay. So what was interesting about this was, and this is a little anecdote that I'll tell you very quickly, we bought an automation system from a major manufacturer because no one made anything that could handle all the complexity and the multiple channels and sensors that we had. In fact, the program that we had was created for like an automotive manufacturing plant where you might have 16 robots working to weld together a car body. So we had our graphic designers and our programmers create this overlay that went in front of a very generic engineering software. We then attached it to all of these various pieces of equipment that had never been attached to this type of software before. When the system worked, it worked beautifully. When it didn't work, nothing worked. So we were on the bleeding edge of making this system work. And the reason this is fascinating to me is about 6 months ago, I bought my girlfriend a Nest thermostat. You know what a Nest thermostat is? If you don't know, look it up. Designed by the same guys who did the Apple interface. It does everything this system did with the possible exception of the moods page, $200. Connects to Wi-Fi to your computer. You can dial in from your cell phone. You can set the temperature you want. You can set days in advance, vacation settings for $200. I won't tell you what this cost, but it was more than $200. So it's interesting. Between about 2010 and say 2012, 2013, there's been a huge change in this, not just because we now are learning how to have this technology because we always had it, but now there's a demand at the residential level for people to actually do this. And I think that's huge.
So we wanted to share a little bit about, that's a lot of information about how we approached the design to meet the competition standards. And we wanted to share with you how we did. And it might help James actually, if you can show. We placed 8th overall. And I will say we did the calculations. We were an expensive project, to say the very least. There were a lot of decisions that we made early on about what we wanted to achieve through this project. And to us, it was more important to pursue innovation and some of these kind of bleeding edge ideas that actually cost more money for you to prototype. So we were last place in affordability in the competition. But placed very well in all of the others. And you can see here a number of competitions we actually did place first place, several third place in there as well. So you can get an idea of how we kind of fared in all of these different categories. And then also on the right-hand side is actually how we fared against our competition. which is a somewhat difficult diagram to read.
Yeah, we're here at 8th, but that just means that we beat Massachusetts, Canada, Florida, Appalachian State, Parsons, Tidewater, China, the entire nation of China, which was great, Belgium, New York, New Jersey, and Florida.
And so one of, when I talk about the things that we wanted to achieve through this project, one of those pieces was, okay, we do this project, we take it to the competition, and then what? That, a lot of teams actually, they have buyers arranged, or they take their project and they place it on a site, and it kind of loses its life from that point. So one of the pieces that we actually did was, in making a single unit and making it easily transported, we were able to take this on tour. So when we drove it up to Washington, D.C., and were able to just pull back the covers, and the other teams realized that our house was already done, that was a fantastic moment. But when we showed up in Nashville, in Memphis, in Chattanooga, and had the opportunity to take it back to Washington, D.C., the mileage that we were able to achieve with being able to talk to school children, homeowners, professionals from architecture, energy, engineering, the whole 9 yards, that ability to actually share this story and to talk about the individual pieces of the home and the bigger idea, and then of course the University of Tennessee. One of my favorite days, we had 2 days of middle school students who came through when we were in Washington for the competition, and when you're standing at the end and you're handing them their little brochure and their button, they were just, I'm going to the University of Tennessee. And so it just makes you really happy to be able to stand there and be a part of hopefully bringing in some new recruits in 10 or 12 years.
Yeah, we're looking for a big increase in enrollment in 12 years.
If there's a spike, we're taking full credit for that. So these are a few examples of kind of the different settings that we were able to take this home. And it did, when we took it to these places, we actually were able to leave it for several weeks at a time and have it staffed and reach out to the local schools and reach out to the professional organizations to host specific events as well as be a part of festivals.
Right, and so part of what we do, we don't just design, we don't just build, we also evaluate. And that's one of the wonderful things we get to do because we still own our home. Most architects, builders, and architects, once they've finished with building that project, they don't get to monitor it anymore. They don't really get to know how it performs in the real world. So we've had the opportunity to do that. Dr. Bill Miller, who is a joint appointment with UT Architecture, Engineering, and works at Oak Ridge National Labs, has been monitoring the home with his graduate students. So we have a sense of exactly what sort of temperature flows are happening in the summer and the winter conditions in our house through our double facade system. So, so we're taking enough data on that very soon we'll be able to know, A, did it perform as we intended, and B, if it did not, what could we do to make it better? And we're benchmarking a code, and he's almost finished with this, so that we can really, in the future, instead of having to build as many prototypes as we did, we can model this in a computer very quickly and get very clear, clean data on this. And that computer tool is very close to being licensed to a window manufacturer right now. So that's one sort of great effect of this, is by putting this much effort in designing these new technologies, people are interested in that. So they're coming to us asking for it. We've also had some interesting encounters with some developers who are interested in this idea of compact living. So just this summer, we ran a studio with some developers from Chattanooga looking at how could we reuse shipping containers, which is sort of a popular idea, but hasn't really been tried yet in this area. So we looked at that. We also are looking at other projects later on that go with this design, build, evaluate theme. We had this house along with the new Norris House, which is another project of the architecture school, at the American Institute of Architects convention just a month ago. So this is something that seems to be a direction that people are very interested in. I think it's helped us attract some of the best and brightest students, and we're very excited to push that forward.
So the kind of closing piece here, we just wanted to share with you. This is, not only did we have hundreds of students and 10 departments and the support of the university and all of its branches, but the support of industry to engage with us in kind of how do we approach this project. They donated products, they have stayed in touch with us, just like James was speaking, the glass manufacturers, all of the components and pieces that went into that. Those groups are very interested not only in keeping in touch with each other to possibly look at deploying some of these systems, but also wanting to know what data we're getting back and what kind of feedback we can give them on those systems. So all of these people made that possible for us to be able to fulfill this project and a dream.
Right. And it was really nice. 2 weeks ago, 3 weeks ago, the Southeast Sustainability Summit was in Knoxville, and about 25 folks came out to the house for a tour. Many of them are from these companies up here at the top, and it was great to have those people all in the same room again. I think it was great for them to see what our students can do. And as I think we talked about before we started this presentation, sort of as a sidebar, the students who have worked on this project, whether they were in architecture, interior design, engineering, mechanical, electrical, they have found jobs placed with some of the highest and best, kind of most cutting edge companies because of what they did on this project. So not only is this sort of work in demand by the students who come here, it's in demand by the folks that hire our students. So it's a really good link between those two. And just wanted to point out, this image was taken on a cell phone. This was Kate Armstrong, one of our grad students, when they were in Washington the second time for the Smithsonian Folklife Festival. So it's pretty nice to be able to sit on your front porch of the house you designed and built and watch fireworks on our nation's capital right there with the Washington Monument in the background. And I think this was a really awesome event. We had 25,000 people see the house just at this one event. We were right there beside the metro stop on the National Mall. We had that 105-degree heat wave in DC that week. So we had a solar house. It was not grid tied. We had our air conditioning running. Both doors were completely open because people were just walking through. And we were able to show them what it felt like to actually be in a solar house in 105-degree weather. And it felt pretty good.
It was about the only, in addition to the heat wave, they also had a huge storm that came through. And so most of the other exhibits had, posts and tents, just like you would normally see at a festival. So as I'm sitting back in Knoxville and able to go with the team up and watching news reports of tents scattered across the National Mall, and I think our structure was the only one that was still intact.
It was.
So it was
nothing happened to
also
ours.
quite a scene for it.
And all of our students went out and helped everyone else put their tents up because we're volunteers and that's what we do.
So, and one other piece that we wanted to kind of offer to you all is actually the home is here on campus, or on the ag campus. It's actually sitting in UT Gardens. And there are hours that it is open. It's usually open around the time of the farmers market. So we encourage you to go out and kind of see it firsthand and let us know what you think.